Hey, today we're going to look at lesson 7.2 and we're going to solve equations, and we could still run into variables on both sides. We're going to still look at things that have multiple steps, but now we're taking a look at equations that have rational numbers. Rational numbers are anything that we can write as a fraction. So that could include fractions or decimals, and that's all that means. We're taking a look here at this equation. 1/5 a plus 1 equals 3/10. And we're still trying to isolate the variable. We're still going to use inverse operations. It's just that we're adding an extra step here. And one of the things that we want to do is we want to get rid of fractions. So we are going to look at how to get rid of a fraction and turn everything into where we're looking at whole numbers or integers. Take a look at the denominators. The denominator here is a 5. And the denominator here is a 10. And there's another denominator. It's under this number here. You just don't see it. It's a 1. And so between 1, 5, and 10, those are our three denominators. The lowest common multiple is this number right here. Multiples, like the multiples of 1 are 1, 2, 3, 4, 5. The multiples of 5 are 5, 10, 15, 20. The multiples of 10 are 10, 20, 30. The lowest common one is a 10. And so what we are going to do is we're going to multiply every term. Okay, we're going to multiply every term by 10. And this is how it's going to look on paper. You're going to put a 10 in parentheses there. And I could put a 10 in parentheses. It doesn't really matter if I do it left or right. And I'm going to put a 10 right there. And now it's time to reduce these fractions. 10 into 10, 10 goes into 10 one time. And I'm going to copy my equal sign down, and all I'm left with here is 3 times 1, which is 3. This 5 divides into this 10 twice. And now I've got 2 times 1 times a, and that just leaves me with 2a. And this last one, 1 doesn't reduce the 10 at all, so it's just a 10. You can't reduce it. It's 10 times 1. So 2a plus 10 equals 3. Now if I solve it, there's my variable. We're going to take away a 10, do the adding and subtracting first. In this case, I'm going to take away a 10 on both sides, and I get 2a equals -7, and then I'm going to divide by 2. And it's okay to get fractions, and we can even leave them improper. We don't really have to do anything to it. My answer could be a equals -7/2. If you really want to divide it out or do the math to turn it into a mixed number, you could have a equals -3.5. That would be fine as well. That's it, and we'll box our answer. Here's our second problem. We've got fractions again, and again, the fastest way to do this is to clear the fraction. We're going to multiply by the lowest common multiple, and it's important to know what all the denominators are. I've got a 3, a 6, and a 2. And the lowest common multiple of a 3 and a 6 and a 2 is going to be the smallest number they will all divide evenly into. So the multiples of 2 are 2, 4, 6, 8, 10. The multiples of 3 are 3, 6, 9, 12. The multiples of 6 are 6, 12, 18, 24. And we want the smallest one they have in common, and you can see it right there. It's a 6. 6 is the smallest number they'll all go into. And so we're going to multiply everything here by a 6. So let's go ahead and we're going to put a 6 there, a 6 there, and a 6 there. We'll put it on top of every one. And now it's time to reduce every fraction. So I know that 3 goes into 6 twice. And notice that 3 turns into a 1 because 3 goes into 3 once. 6 goes into itself once, and 6 goes into that once. And then 2 goes into itself once, and 2 goes into 6 3 times. So now we've reduced all the fractions, and we just got to multiply all the stuff that's left on the numerator side on the top. So that's 2 times n. That leaves us with 2n minus, and 1 times 1 right there. 1 times 1 is 1, and equals, and then 1 times 3 is 3. And we're going to go ahead now. We've got a simple two-step equation. This is what it looks like when there is no fraction. We'll just add a 1 to both sides. We do the adding and subtracting first. That leaves us with 2n equals 4. Last step is to divide, so we're going to divide both sides by that 2. And we'll get n equals 2. That's our solution. It's the only value that'll make it true. We aren't going to check it simply because fractions are quite annoying to check. We're going to skip an example. I know I skipped one, I think, on the lesson. And we're coming down to this one here. We got a new variable h. I got a bunch of plus signs, so I don't usually have to worry about too many integer mistakes. But let's take a look at the denominators. We've got another fraction we want to clear. I got a 6, a 3, and a 4. And out of a 6, a 3, and a 4, we want the smallest number they will all go into. The multiples of 6, 3 will go into 6, but 4 will not. The next multiple is a 12. 3 will go into 12, so will 4. That means that 12 is going to be my lowest common multiple. So we're going to go ahead and multiply every one of these numbers by a 12. That'll be a 12, a 12, and now it's just time to reduce these fractions. 6 goes into 12 twice, and 6 goes into itself once. 3 goes into itself once, and 3 goes into its 12 4 times, and then 4 into 12 3 times. And of course 4 into 4 once. And I want to highlight the reason we use the lowest common multiple, and if we choose the right number, all of our denominators should be a 1. And that's how we clear a fraction, or we get rid of a fraction. We need those denominators to be a 1. So if I multiply what's left, I've got, we can see here, I've got a 2h plus, I still don't forget all the things that might be left. There's a 2 and a 4. So that's 8. 2 times 4 is 8 equals, and then 5 times 3 is 15. So when I go ahead and subtract the 8, again, we're back down to two-step equations, basic 7th grade math, really. Just don't make an integer mistake and we're okay. We'll divide by 2, and we'll get h equals 7 halves. And that's okay. We could box it and leave it as an improper fraction. There's no reason to write h equals 3.5, but some people just don't like looking at those improper fractions, and so 3.5 is okay too. We would probably prefer not to get a decimal for an answer because the equation has fractions, so let's go ahead and answer it with a fraction. We don't need calculators that bad. This math isn't super challenging. So here's about maybe a pretty challenging problem. Notice we got 2 terms on each side. I got this term here. I have 2 variable terms also. I have x over 3 here, and here I have minus x, and there's no fraction. So let's take care of that. We do want to kind of make this something that looks consistent. It's easier when they're all fractions. So this says minus x. I know from experience that should be a 1, and I'm going to put a 1 underneath, and now they are all fractions, and now I can deal with them. My denominators are pretty simple, 3, 5, 3, and 1. And between a 3, a 5, a 3, and a 1, the only number that they'll all go into, the smallest one, the multiples of 3 are 3, 6, 9, 12, 15, and the multiples of 5 are 5, 10, 15. And 15 is the smallest number that they will all go into evenly, so that's what we're going to multiply by. 15 is the lowest common multiple. So I'm going to go ahead and put a 15 in parentheses here next to all the terms, and sometimes it helps if you spread out the problem that you're working on so you have room to write that 15, but I'm just copying what I had less in the lesson. Don't have a ton of room. Let's see here. 3 goes into itself once, 3 goes into 15 5 times, and 5 goes into itself once, and 5 goes into 15 3 times. 3 goes into itself once, and into 15 5 times. And now it's really important that we make sure to remember that we got to get all of the terms on the top multiplied. This is 5, and that's x. Don't forget the variable. 5x plus 2 and 3, that makes 6. That's what's left, 2 there and the 3, that's plus 6, equals, and then it's 2 and 5, that's what's left, 10, minus x. You could put 1x if you want. I guess I'll put a 1 just to make it simple. Now I got letters on both sides. I got an x here and an x there. Move the smallest one. The smallest one is minus 1x because minus 1 is less than 5. So we're going to go ahead and add 1x to both sides. And 5x plus 1x is 6x. Plus 6 equals 10. And now it's pretty simple. Now you can probably guess what we're going to be doing next. We got to get rid of the plus 6. do the subtraction step, that's 6x equals 4, and when I divide by 6, we're going to get an answer. Always want to reduce your fractions. Don't call it 4/6. That's 2/3, and good to go. Okay, we're going to finally take on the very first example in the lesson because it's taken a while to build up to that, and this is a fairly challenging problem involving fractions, but hopefully by now we have enough skill. One of the things you're going to see on this is there's very little room to write in a problem that the textbook gives us. I'm going to remind myself that everything should be a fraction. This is 7/10, 3/2, 3/5, but that's just plus 2, and I'm going to put a 2 over 1. And now I'm going to rewrite everything, and I'm going to spread it out because I need room to work. So let's take a look at what that might look like. 7/10 n plus 3/2 equals 3/5 n plus 2 over 1. The reason I do that is so that I have room, so that when I want to start multiplying by a lowest common denominator, that I've got some room to put that number in. It looks a little bit cleaner. Let's take a look at the numbers I got. I got a 10, a 2, a 5, and a 1. If I take a look at a 10, a 2, a 5, and a 1, what's the smallest number that they can all go into? I'm going to start at the biggest number, and I'm going to go ahead and list the multiples. Can they all go into a 10? 2 goes into 10, 5 goes into 10, 1 goes into 10. If that one works, you don't have to go any farther. I could have used 20 or 30 or 40. Those all would have worked, but 10 is the smallest. So we're going to multiply everything by 10. So I'm going to put a 10, and now you see why I chose to spread it out, because it gives me room to write a 10 next to everything. Let's take a look. So 10 goes into 10 once, and that's going to take care of that. 2 goes into itself once. 2 goes into 10 5 times. So we're just reducing our fractions away. 5, 1. 5 goes into 10 twice. And always mindful, don't forget that that was a 1. You can't reduce it with anything. So you're left with 2 times 10, that's 20. I'm going to go ahead and start to shrink this up a little bit. 2 times 3, 6n equals, and then over here, 10's turned into 1. So make sure that you don't forget the 1, but you got the 7. That becomes 7n plus, and then 3 and 5, 15. Now, perfect example, which ones do we move? Take a look and think about it. Which one's smaller? We're going to move that variable first. That's whenever we got variables on both sides, let's get the variables together first. 6n is smaller, so I'm going to take it away. I'm going to do the opposite. It was a positive 6n, so I'm choosing to subtract. So we'll take away 6n. That's how you undo that. And should have made that line longer. 7n take away 6n. 1n plus 15 equals 20. And last, I'm going to get rid of the 15, take away 15. That's the last step. And you're going to be left with n equals 5. And that's going to be our solution.